Okay, so this video is going to cover on how to find the area of different kinds of triangles. So hopefully we do know that there are all sorts of different kinds of triangles. So we have a right triangle, which is a triangle that has a 90-degree angle in it, which is a right angle. We can have an isosceles triangle, which means that 2 out of the 3 sides equal each other. So you have 2 equal sides, the third side is different. We have an equilateral triangle, which just means that all 3 sides are equal. Or we can have all different sides of the triangle, so that's not a very good triangle right there. But that would be something like maybe this here, where every single side is different. Right? So there's all sorts of different triangles, and okay, right, so there's all sorts of different triangles, and depending on what kind of triangle you're given, and then furthermore, depending on what type of information you're given, we may have to go about solving the problem a slightly different way. So taking a look at the top triangle I have here on the screen, right? So this triangle here has given us a lot of different information. Now the formula that I have here at the top of the screen, this is the typical formula for area of a triangle. Area is equal to 1/2 times the base times the height, right? But of course this formula is used if we have the base and the height of the triangle. So the base being the bottom of the triangle or what it sits on, and the height would have to go from that base all the way to the top to the point or the vertice of the angle across from it. Now we do know that a triangle has 3 different sides, so we could turn the triangle around. It would not matter what side we use as the base, as long as we knew the height from that base to the vertice of the angle opposite it. So taking a look at this example here, we do have the given information that we need. So this triangle has given us that the base is 13 inches and that the height is 8 inches. So for this particular one, we can use the formula as is. Area is equal to 1/2 times the base, which is 13, times the height, which is 8. So for this one here, we can go ahead and just plug and chug this into the calculator. So 1/2, you can use 0.5. 0.5 times 13 times 8. Right, and here we would get 52 square inches. Remember, we are finding the area, and area always has to have your unit squared. It's a 2D figure, therefore that's why we have that little 2 there. So just 1/2 times 13 times 8 gives us a total of 52 square inches for this one. Now taking a look at the second triangle that I have here. Right, so I see that one side is 7, the other side is 7, and then I have a 12. So I know the lengths of all 3 sides of my triangle. I don't see a height here though. So I don't see anywhere on here where it says maybe 12 to the vertice opposite, but we don't have a height from that. Or if I take a look at the other side where they have the 7s, right, I don't have anything on here that would let me know what those are. So we need to get a little creative here. We need to think a little bit outside the box and try and figure out, okay, what are we going to do here? Because we can't use this formula 1/2 base times height. I would know my base, but we have no idea what the height is. And without that, we can't plug and chug into this formula. Now, thankfully, though, somebody has created a formula for when we do have an isosceles triangle. All right, so we do have 2 sides that are equal. Therefore, this is an isosceles triangle. And over here on the screen, I've brought up the formula for an isosceles triangle. It does look a bit scarier than the other one, but it's still very much doable. Now, one thing we do need to keep in mind when we are plugging into this formula, so notice this formula, 1/2 b times the square root of a squared minus b over 2 squared. Right, so for this particular formula, it looks like we would need to plug in for A and we would need to plug in for B, so we need to know what those are. So over here off to the right side of our screen, I've drawn this triangle here. So A represents the sides of the triangle that are equal to each other. So the 2 sides that are equal, that are the same, those are going to be our A. B is the third side that's different, right? So for this particular example, A is going to be 7, right? And B is going to be 12. Okay, so now we just need to plug and chug into this formula. So area is equal to 1/2 times B, so B is going to be 12, times the square root of A squared, so 7 squared, minus 12 divided by 2 squared. Now we do have some simplifying that needs to happen here, so hopefully we do remember our lovely order of operations. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. It tells us the order in which to simplify a problem. So taking a look at the problem that we have, right, so we have a lot of different things going on. 1/2 times 12 times the square root of 7 squared minus 12 divided by 2 squared. Okay, so what we need to do, so that square root symbol, we kind of treat that almost like it's a parentheses. We need to simplify everything underneath that square root symbol first. And underneath the square root symbol, we have a few things going on. Right, so for right now, I'm going to drop down the 1/2 times 12. If you wanted to go ahead and calculate half of 12, that's fine. Just leave that outside the square root for now. I'm going to mess with what's inside the square root. So inside the square root, we have 7 squared, which is 49. And we're going to subtract, well, 12 divided by 2 squared. Well, 12 divided by 2 is 6. And 6 squared, so that's 6 times 6 is 36. All right, so inside that square root, we have 49 minus 36. Okay, and our next step here, I'm going to go ahead and take half of 12. Half of 12 is 6. And we're going to multiply that by the square root of, well, we got to do that subtraction first, don't we? We have 49 minus 36. And when we do that subtraction, I'm getting a 13, right? 49 minus 36 is 13. So we have 6 times the square root of 13. So go ahead and use your calculators to plug that into it. The square root of 13 is about 3.6. And if we multiply that by the 6 in front, I get 21.6333. Now, if you're doing this for a class or anything like that, I would just say make sure that you either note in the problem what it has to get rounded to or what your teacher typically expects your answers to be rounded to. For the purposes of this problem, I'm going to go ahead and just round that to a 10th. So my 10th place is right there with the 6, so that means this would be rounded to 21.6. And it looks like this one here is in feet, so that's 21.6 feet squared. Remember, don't forget the area, you always have square units. All right, so you can see here how the process was a little bit different for finding the area of this triangle because we did not know the height. So this one here, 21.6 square feet. Okay, so our last example here, so I have this triangle here. Once again, I do not notice a height to this triangle. Now, taking a look at all the sides, they're all the same, right? 22 is the same as 22 is the same as 22. So this is an equilateral triangle. I do not have a height going from the base to the vertex of the opposite side. So okay, so we can't use our basic 1/2 base times height formula here. Now, thankfully, we do have a formula for the area of an equilateral triangle, and it's right over here. It's a lot simpler looking than the Isosceles one. So taking a look at that formula, it looks like the only thing we would have to plug into that formula, well, let's see what the formula says. It says 0.433a squared. So a is the only thing that I see in that formula, the only variable that we would have to plug into, and a is just the side of the triangle. They're all the same, so just take that number and plug it in. So for this example here, this would be area is equal to 0.433, and our example here, our side is a 22, so that would be 22 squared. Again, following order of operations here, we do take care of exponents before we multiply. So we want to go ahead and do 22 squared. 22 times 22 is 484. And the only other thing we would have to do is multiply it by that 0.433. And when we plug that into the calculator, I'm getting a 209.572. Okay, so once again, depending on what you would have to round this to, I'm going to round it to the nearest tenth. So we have a 5 there, which means we would be rounding this up. So 209.6 centimeters squared for this particular problem here. All right, so as long as you have the formula, this one's pretty easy to do, right? Just plug the side in, square it, and multiply it by that decimal. So the area of this triangle, 209.6 centimeters squared. So you can see, depending on what kind of triangle we had, depends on what formula we're going to use, and then we do need to know how to plug into those formulas and what pieces of information we need to graph from our pictures. So do make sure you are careful and you do notice the difference between the different kinds of triangles.